constraint, the main constraint, depending on the DBMS system database model, they provide more constraint. So one of the examples is the semantic, which is called the semantic integrity constraint, which means in this example we have salary. So salary should be bigger than 10,000, less than mine. Okay? So that is the constraint. That is the condition. But can you implement such a constraint using primary key? No, because that is for uniqueness. What about entity integrity? It's not none. We cannot implement. What about the referential integrity? No, it's too specific. So this kind of the constraint is called the semantic constraint. Semantic integrity constraint that can be implemented by separately. One of the way is in SQL 99. What is that? Certainly it's a SQL 99. Actually it's a standard name. So we have the level of the standard SQL 92, 99, 2000, SQL 1, 2, 3. So we will see a little bit more about that history. But anyway, it's a kind of standard. At the time, SQL 99 suggests trigger or assertion. So but trigger is more popular. Actually same thing, but to implement such a semantic. For example, if you are the inserted, like you are new employee, okay, then it's okay, 113, and name it, salary is
500,000.
million. It's higher than mine. So there is the separate, the process. It's kind of process, actually not process. In the DBMS system, keep checking. Whenever this salary is updated or inserted, check whether value is bigger than Professor Lee's salary. In case higher, then do something. That is based on ECA rule. Anyone who heard about the ECA rule? Event, condition, and action. So this is called the ECA rule. So ECA used a lot actually in computer. If then else, for example. So if then else is if something, then condition and do something. So in case something happened, in case the salary is inserted or updated, check whether that is higher than Professor Lee's salary. If yes, fire him. Or you can lower. Then there's somebody who has the permission and approve or decline, something like that. That is called trigger. So who will practice trigger? Most of, not all DBMS provide such a trigger or assertion, but most of the DBMS provide it. Then finally, we can have such a data. This is called relational, because it's based on the relational model. Database is a database schema. It's a description. So this is our, so we can use the box to represent the table or relation and separate. So by the attribute underline for primary key, as you can see, all table has one primary key. What about this department underbar location? Why is 2? Actually, it's a 1. It's a composite primary key, only 1. The composite primary key is allowed. P number is a 1. Okay. ESSM plus P number is unique. Okay, and non-none, and so. However, this one does not show foreign key relationship, referential integrity. So we can find based on what? chapter 7 handout requirement. Okay? So, for example, employee should work for department. At that time, we can use arrow, referencing, start from the referencing, target on reference. Many of the students opposite in the exam. I keep mention about this. So starting from where? Referencing. This one depends on this is a target, reference. So be careful for the arrow. Can you find any other? This D number, refer this one. Also, P, D number in project. Yes, D number. No. This D number. Okay. Don't be you should be careful. Name of the attribute. It can be A, B, C. Actually, it's okay. It is not recommended, but it's okay. If you want to name it A, B, C, but in terms of context, here is the referencing D number in department. Okay. What else? Can you find anything else? ESSN is employee SSN from SSN. And also this one, this. And PNO is the P number project. This manager social security number should be here. That's it?
No.
There might be one more.
P name.
P name? This one? No, I don't think so.
No.
Super SSN. Even sometimes you can refer the same table. Okay? That is the recursive. Okay? This is a foreign key, referential integrity. It's our final goal. If you can do this one, the database design is done. Okay? Since you are very familiar with the company database right now, it's easy to identify the number of a foreign key. In real life system, if you miss one of the foreign key, you cannot realize right away. Sometimes 1 or 2 years later, you realize there's such a problem. Okay, so you should be careful when you define this one. Okay. Any questions? So this is our goal actually to design. So in your page one is kind of the defining the problem. So you will make the problem requirement. You will state by yourself for your statement of the database system. In page 2, you are going to design conceptually. At the time, ER model, using the ER model. Okay. Step 3, that you will make the database schema as well as the query, database query. Then finally, implementation. So this is the relational database schema for the company database. Then, if we insert the data, can you remember that? What is the database modeling? Modeling is include not only just the constraint, but also operation. We need to do something. Sometimes I use the example of the building a house for the database design. Okay, it's quite similar. You can make the blueprint like using your idea, so this conceptual design, and you can draw the details of your design of your house. That is the database design. Then finally you can build. And also after you build the house, you should be able to use that house. You need to know where is the entrance door and what is the number to unlock your door. And if you enter, then you need to turn on the light and should be the operate, right? So database provide the SQL. Actually, for the SQL, there is a relational algebra and calculus. We will discuss next week and next week about this one. Using that, we can populate the data. So we can insert the data by following 3 constraints that we have discussed. Even though it's not mentioned the details, so these data follow such a constraint. Then this is called company database state. That's our goal. Do you remember the database state means database schema plus sample data instances. So this is our goal to create. So this is the final output. Are you doing everything?
Yeah, I do.
That is the reason you need to preview. You need to study before you come here. Okay, then, as I said, we need some operation in relational database. That is the insert. To insert the data. One good news is most of the database language is very human friendly. So straightforward to understand. So insert, you can insert the data. Delete, you can delete the data. Modify, we can use update. Actually, we use update command to modify the data. Okay, and also we can give the integrity of that. Okay, we will learn the details about such a thing later. Okay, this is the bookstore. Bookstore or enrollment course, some part of the student database. Okay, we have 1, 2, 3, 4, 5. Actually, they are connected. So one primary key. So, for example, student has a social security number, and as a primary key, of course, as a course number for the primary key, and so on. So we have the 1, 2, 3, 4, 5 tables, 5 relation with the 5 the primary key for each. Can you imagine? Can you draw the foreign key based on the name of attribute? Okay. What can be the first foreign key you can find?
Major to department?
Department, major, department. We do not have department. So it's not foreign key. SSN should depend on this one. So from here, reference.
Cost number?
Customer. Course number.
To cost number. And row cost number to cost.
This is yes. This one?
Yeah.
Yes. And many of the students sometimes, what about this?
No.
No relationship for that. Both of them.
Both go to cost number.
Yes. Okay. And the book, ISBN, this one to this. Alright. Okay. And here you may realize most of the reference column is what? It's a primary key. But I said most of, which means sometimes not. When? It can refer candidate key. Okay? Because they are also unique. So it can refer primary key. Doesn't make sense if this is duplicated. Okay? Non-unique. How do you know which one is which? You don't know, right? So only primary key or candidate key can be referenced. Okay? 1, 2, 3, 4. 1, 2, 3, 4. Yes. 100. Thank you. So that is a relational model. Actually, relational model is simple. That is one of the benefits of using relational database model, because it's simple and it can be generally applied. So it works very well. By the way, before we move to the next one, actually I tried to discuss the before, but I remind them, why do we use the database? Organize the data.
For people, for the users. For storing organized data.
So it's a controversial. That's true. So organize the management issue. Okay, and also what? Store the data.
Yeah.
You can store the data in file system also, right?
But if we have
Size.
size,
Yeah, because it's a big. So what about the backup drive? It's a 1 terabyte backup drive. You don't use the database.
For analysis?
Analysis. You can use the Microsoft Excel. So in my opinion, it's my opinion. So based on my experience of the working in the company with the real database and also teaching the courses and research, the one of the main reason, first reason of using the database system is search data quickly. Okay, so that's another reason, the most important reason. But it's controversial. Somebody said the management and security is the first issue. Maybe true, but in my if database is slow, okay, you don't have to use database system. You need to think about the other, the way, like the file system or some other. The relational model also focus on how to access the data very fast. Because of that, it has a lot of constraints. Okay? Not only for that, but also the other reason. But first reason is the accessing the data. Primary key. If we do not have the primary key, very hard. Even though I can find the very fast 2 or 3, we don't know precisely, right? So because unique, we can easily find. Also similarly, because not null, so we can use the primary key to access the data very fast. Then, using such a primary key, we can make the index, like your textbook. And with your textbook, you can find the index. So using index, so you can easily search the data. Exactly what 99.99 same architecture. The index used in the relational database model as your index in your textbook. Okay? So that is the first. And what about the referential integrity? That's the same reason I did. So if we do not keep the referential foreign key, it works, but you may lose the chance to find the data very fast. So that is one of the reasons. So which means if you have the duplicate data, redundant information, that's critical to search the data because you don't know. However, information retrieval is different. Database search, we are focusing on the database search. What about the information retrieval? What is different? Information retrieval and database search. Information retrieval is like the Google. Googling is the information retrieval. You don't care how many pages are written. You don't care. Even though I I'd like to search what Professor Lee is doing, so the type the Lee, a lot of different Lee, okay? Right? So as long as the web page include the LEE, it will return, it can be blue jean, right? So it can return any, the Lee. So, and they rank, okay? They don't care whether this web page is correct or not. However, database is 100% correct. You don't have to worry about whether output is correct or not. Unlike the Googling. Googling, you need to check. Sometimes you need to do the several times, or you need to go next. Google is not the god of search, actually. Okay?
What if you use the right Google Docs?
The Google actually envy the Facebook because of that. Why? Facebook has all the information about yourself, the user. For example, when you type the link, if you post some status, your personal status on your Facebook, like the Professor Lee, he's worst professor at something like that. Then Facebook knows who is Lee. Okay? So when you type the link, the Facebook will consider your message. What about the Google?
No.
Google cannot do that because of the Google envy, a lot of Facebook. So which means it's a information retrieval is a very subjective. However, database, because of the many constraints, we don't have to worry about whether output is correct or not. It's always correct. But problem is the speed. Okay? So that's what I'm thinking. The database should be first fast. That's the first thing. Okay? Then next thing is we have ER model, conceptual model, we have database model. So this part. So in this, the next chapter, we will convert ER model to this database model. You already realize it's quite similar, right? Let's see this one. This is a ER modeling, ER diagram, right? Then what about this one? It's a database scheme, relational schema diagram. They are quite similar. Okay? However, it's different. So we are going to compensate such a difference to be from here to here. The first is a step-by-step actually. It's a very straightforward step-by-step. First, we are going to consider one by one, like the first entity, next relationship, next weak entity, and next the special thing like the multivalued one or the delight or not, and the composite attribute, something like that. So we are going to start from the entity type, like the student, department, and so on. As you already realized, employee, also employee table, and department table, and project is a project table. Okay, so if you when you convert ER model to relational database schema diagram, for the entity type we create relation table. Then one of key. This is a strong entity. It's not weak entity because a weak entity does not have key. So that's the problem in the relational model. So later we will consider. So we can use the key attribute as the primary key. But how many key attributes? One or more key attributes. We need to decide one of them as primary key. One primary. So that's it. So we can select the social security number for the employee, or D number for the department, and the P number for the project. Then what about the other attribute? The other attribute will be attribute column of relation. Very simple. So that's it. Next, the weak entities problem, like this one. However, we already identified what? This is partial, okay? Or this cannot be primary key. Then what did we identify? Identifying relationship with the help of prime key of identify entity. We can identify the dependent. So we can bring this one to here to make primary key. So primary key is what? Social security number plus name. I don't think there are families who named their children identical name. I don't think so. It is possible to use the father's name, but even at that time we can use the junior, senior, and third. So we can identify. So weak entity. What is the primary key? Primary partial key plus primary key of identified entity. In this case, social security number plus name. One more thing. You need to create foreign key. Because this SSN, to differentiate, you can use the ESSN. This is a primary key. But this ESSN from where? This one. So add the foreign key. So that is the reason. So you can see ESSN refer the SSN in employee. There might be a question. How can I name? This is a ESSN, this is a D number, this is a DNO. There is no general rule in database for the naming. However, naming in database, as I said, like the C1, C2, C3, T1, T2, T3. So as long as it makes sense, so it is okay, but you should be careful. Most of the project, if you join the big project, your project manager usually have such a naming book, very detailed naming book. For example, when I joined the first time the database project, so name should be the one character of the very higher level, the project, and details of 3 level and underbar, and describe the table within the 7 or 8 character, and then number, something like that. You need to follow such a naming. Otherwise, in the classroom project, as long as we can understand, okay, that will be fine, but please add some prefix, proper prefix. Number is not always recommended in database naming. I don't know why, but not many database, the table or attribute, they are using number, unless that represents a specific month or year. Okay? Sometimes transaction 1 represents January transaction. Transaction 2 or February, something like that. But even that time, I don't know why, not many. The database object use the number for their name. So we already did first step and second step. First step, entity will be table, the key attribute. One of the key attribute will be primary key, and weak entity, you can create the relation table with the primary key. How can you make the primary key? Using identifying a relationship. Then bring the copy, the table, the social primary key of that. Also, you need to create the foreign key. So we will continue the other step, okay, from step 3, next class. Also, one more thing, I think that we have the exercise slot March 3rd, Tuesday, and March 10th, the Tuesday, right? Then 12, we will have the midterm exam. I'd like to change the March 3rd to the March 5th. The all Tuesday exercise slot to the Thursday, which means our midterm exam will be March 10th, okay? Tuesday. Is it?
So we have one lab.
The same number of lab, but move Tuesday to Thursday, okay?
So it was on like the 10th.
Any problem?
So just do it to that.
So we need to change the.
Yes. Because